Welcome to today's Home Remodeler. I'm Stuart Keith, and on today's show, well, we're learning more about solar hot water systems. Next, we'll catch up with Justin Castleman from Castleman & Sons Plumbing, who designed and installed a solar hot water system in this new home. Justin, what a beautiful home. Obviously new construction, but it looks like it's turning out just beautiful.
Absolutely. The customer was in the middle of building this new home and contacted me looking to do some renewable and try to incorporate something into the project. And we looked at the site and decided on solar hot water.
Okay, so when you say solar hot water, that's the domestic hot water used for clothes, dishes, showers?
That's correct.
Now, you know, we were just at a commercial site and they had the big array of collectors out there, and I kind of expected to see that here at a residential setting, but you've done a masterful job at hiding those collectors. Where are they?
Well, based on the site requirements here, the panels are actually on a south-facing elevation, so they're on the other side of the house, and they blend in really well with the home and the roof lines.
Are you finding that solar hot water is becoming more mainstream?
Definitely. We're finding whether it's new construction or a retrofit on an existing building, there's a lot more interest in it.
Well, it seems to make sense to me. Let's go around and see how you incorporate it on this roof.
Well, Stu, here's the two 4x8 panels that make up this customer's array. And as you can see, it blends in really well with the roof line and the colors here in the house.
Boy, you know, if you were just walking around here and didn't happen to look up, you'd never notice it. It's really unobtrusive.
That's correct.
And so, as a homeowner, just heating domestic hot water, that's all I need is two 4x8 sheets, at least in this application.
This will do the majority of the load for this customer on average year-round.
So, on a day like this, it's cloudy out, about 65 degrees. Is it an effective system under these conditions?
Even on a day like today, as long as there's a temperature differential between our panels and the stored water in the basement, we will kick on and turn on and collect energy.
Okay, so the glycol solution circulating through. Day like this, how warm is it getting?
We can easily see 105, 110 degrees of collected temperature.
No kidding.
Absolutely.
So that tells you how efficient these systems are. Now, what about in the winter time? Say it's 10 above zero. Is it still effective?
Yes, as long as there's a temperature differential between the panels and the stored water, the system will kick on and collect heat energy, you bet.
Sunny day in January, it's zero outside. How warm is the glycol going to get then?
On a sunny, cold day, actually we've seen temperatures in January of 140 degrees in the stored water.
Wow, well there you go. I mean, it can work in virtually any climate, any location. What about in the winter when it snows? Is there much maintenance with the system? Do I need to get out and sweep it off?
No, not at all. The systems are designed to be maintenance free. The snow will actually slough off of the panels, so there's no worries there. The customer just sets it and forgets about it.
The nice thing is, it sounds too good to be true, but it isn't. It actually, a lot of peace of mind that comes with it. You set it and forget it. Let's go downstairs. I'm anxious to see what the components are down there.
Well, Stu, here we are on a cloudy day, and as you can see, the system is functioning right now. Our collector temperature is 95 degrees. Our stored water temperature in the bottom of the tank is 85 degrees. And our peak high was actually 155.
Wow, so it does get extremely warm. And you mentioned that it's 85 degrees. You know, I think of domestic hot water, I want that to be about 120 degrees. So is it only 85 degrees that I have with the system?
Well, that's the nice thing about this dual coil storage tank. The solar coil is in the bottom of the tank, and the temperature that we're sensing is in the bottom. The heat actually rises, and up here in the top of the tank, we're actually closer to the 120 degree mark.
Okay, right where you want to be. And then the high, you said, oh, is about 155 degrees. You could scald someone with that type of temperature. How do you protect against that?
Well, here we have a thermostatic mixing valve, and what this does is it takes cold water and blends it with the hot and guarantees a certain temperature on the outlet side, so we can guarantee the customer will never have a problem with hot water.
And that's an excellent case in point of when you install one of these systems, take advantage of the solar energy that's out there. You still want to be safe. You want to have a licensed plumber and one who's experienced with this type of technology so it's installed correctly and safely.
Definitely.
You know, when I first walked down here, I was expecting to see a much larger footprint. This doesn't look all that much bigger than a traditional water heater.
That's correct. It's really a 3x3 area. This again is a 119-gallon storage tank. It really is not much larger than a standard water heater.
Boy, it looks like it's very well insulated.
This is so well insulated, there's less than half a degree loss per hour.
It's just amazing how the technology has really evolved. And I think back to the 80s, and there's kind of a stigma out there about solar energy. Sure, it sounds great, but the equipment would fail, there were problems, there wasn't much peace of mind with the system for the investment you were making. Has it evolved?
Definitely. The equipment is better, it's more efficient. The systems today, the longevity is there.
Now let's quickly walk through the operation of this particular system.
Well, this is our domestic water heater. The solar coil is in the bottom. This is our controller and our pump. When the controller calls for heat, the pump kicks on. Our transfer fluid, or our glycol, is stored in this drain back tank. The pump pulls that transfer fluid down through the solar coil, sends it up to the array on the roof, and then it falls back to the drain back tank by gravity.
Boy, the nice thing about it, it's been running the whole time we've been talking here. You can barely hear it. We're not using fossil fuels. And everybody benefits when a homeowner takes the initiative to go with green technology. Thanks a lot for coming on and showing it to us.
Thank you, Stu.